This video is sponsored by CuriosityStream. Get access to my streaming video service, Nebula, when you sign up for CuriosityStream using the link in the description. It's been half a century since Neil Armstrong's one small step, and it's time for humanity to make another giant leap. But where to? A common debate these days is whether we should go to Mars now or wait till we return to the moon, and usually with the intent of having a permanent moon base set up. Today we'll be asking which is better, or if maybe a third option is better than either the moon or Mars first. Now, I don't make much of a secret that I tend to favor a robust lunar setup as a precursor to going to Mars, or even doing them in tandem, but we'll be trying to examine the case for each today, and in the context of today. Many of the arguments for one or the other have been dependent on the situation of public support and available technology at the time the case was being made. And that is a fluid setup, but sometimes the arguments lag behind. Existing space infrastructure might matter a lot in the equation too. For instance, the concept of asteroid mining has surged in popular interest in recent years, and a near-Earth asteroid might be converted into an Aldrin Cycler, a sort of ferry craft between Earth and Mars, or Earth and other planets for that matter, so we will look at the possibility of asteroids first as an alternative to the Moon or Mars, and also Venus first and Jupiter first and some other lesser known scenarios. But our main focus for today will be the Moon and Mars. And without further ado, grab a drink and a snack and let's jump on in. So for most of us who love space travel, the answer to if we should do the Moon or Mars first is yes please. We don't care which happens first, so long as it is both eventually and every other place too. The key concepts of going to the Moon before Mars is that the Moon is more important as a first step than Mars, or that it makes going to Mars easier. There are many arguments often made, but some probably are less valid than others, and let's begin with one that has a number of both, namely that setting up a base on the Moon will help us learn better how to do so on Mars. On the one hand, yes, this is very true, but we also need to keep in mind that living on either has very little in common with each other. It's a bit akin to saying that learning to live in the Sahara Desert teaches you about how to live in Antarctica, or at the peak of Mount Everest or in the Marianas Oceanic Trench and vice versa. There are going to be good lessons that adapt well between each case, but by and large, adapting to these environments is so different that you cannot assume mastering one makes you ready for the others. On the flip side, learning to extract oxygen from lunar regolith to fill structures so we can breathe on the Moon, and learning to keep those airtight, is going to translate decently to Mars. Same for converting ice to oxygen and water if it turns out the Moon has accessible amounts of those. That's something we still don't really know, whereas Mars certainly has them. It's also worth keeping in mind that these two worlds, Mars and the Moon, may be very different from each other, but they're also different from themselves. I used various examples from around Earth to emphasize how different Mars and the Moon were from each other, but the examples illustrate how different bits of Earth are from other bits of Earth, and we should not assume either the Moon or Mars are monolithic and homogeneous. Indeed, we know they are not, and so even a base built in one part of the Moon isn't a perfect blueprint for a base elsewhere on the Moon, and the same for Mars. Such being the case, it really challenges how useful a Moon base is for learning the lessons we need for a Mars base. It might be more practical to just do prototypes and demos on Earth, given the difficulty of building them on the Moon. If you really need an airless bit of desert to practice in, we could always put a big dome over a bit of existing desert and suck the air out, and probably easier and cheaper than building a moon base right now. So too, I said we could learn to make oxygen from rock or ice on the Moon and apply that technology to Mars, but it's even easier to do that right here on Earth, where all our industry and scientists and engineers already are. In terms of valuable lessons learned, we would pick up a ton from doing a moon base, but we'd also learn a ton from doing the Mars base that would help on the Moon. The advantage of doing the Moon first in terms of those two options might be that the Moon would be cheaper and easier to try first, but that's debatable. What isn't debatable is that the Moon is so close to us that signals take only a few laggy seconds to go back and forth, versus several minutes for Mars, and that ships need a few days to get to the Moon with current drives, versus months for Mars. So if you screw up, someone can be online helping you in moments, real time. and evacuation or new supplies might be available in a short enough time that a person who had to escape a base in nothing but a spacesuit with an extra bottle of air and water might still be alive when help came. Not so for Mars. Critical failure there is going to be a lot harder to avoid and survive. Nor can we remote control robots from Earth on Mars like we can on the Moon. That said, those same signal and travel delays are still in play on Mars when you head there, whether you have set up shop on the Moon or not. We also probably should not be sending missions to either with people on board until we have modeled and tested failure options, to the point that one happening would be highly unlikely, and most of the failure scenarios can be tested just fine on Earth anyway. It's more about handling unknown unknowns, and those will exist for Mars, whether we found some on the Moon first or not. We also need to be asking ourselves how much risk we are willing to take. I am quite sure we could find qualified volunteers for the trip who would go even if the odds were rated 50-50, but I would have difficulty imagining many current major nations or corporations being willing to launch with odds that bad. Even 90-10 for Mission 1 is asking for trouble. It is one thing for everyone to say they accept risks, it is another after the fact. Success requires no excuses, failure tolerates none. And while there is no substitute for real experience in dealing with potential problems, we never aim for trial by error, and we can do a lot of preparation and redundancy, gold plating systems to be robust, durable, simple, and easy to replace or repair. We probably are not going to lose a Mars base because it sprung a critical air leak on some seal, where had that happened first on a Moon base we would be fine. You lose it to stuff nobody saw coming, like the Mars base getting eaten by indigenous giant sandworms, which presumably do not dwell on the Moon anyway. Alternatively, a big problem on the Moon that was not really expected during the pre-Apollo buildup was the moon dust. The regolith on the Moon isn't weathered, it is sharp and sticks and clings to everything, and represents a giant maintenance headache. Martian dust is also problematic, but differently than the Moon, and probably less of a headache, but the same basic concepts are in play. Neither world has soil, they are not weathered down, and they may be toxic, and require major efforts to render safe and useful as a growth medium for plants. Managing them to prevent them damaging equipment may require different approaches, but would probably have a lot of overlap. So what emerges is that the argument that starting on the Moon will help us on Mars is valid, but only so much so. That still leaves us proximity though. The Moon can be reached by signal near instantly, and emergency resupply or help or evacuation should be available in a few days, possibly less. However, in reality, even the idea that we could send help to the Moon in mere days is not necessarily as handy as it sounds like. For a well-resourced and well-trained team, you can probably make do against emergencies that aren't rapid and catastrophic, like the roof blowing off your habitation dome. There really is not likely to ever be a manned mission to Mars, and probably not the Moon either, which does not have some robotic component, a 3D printer, and either large reserves of air, water, and fuel, or devices for making them on-site from local materials, what we call in-situ resource utilization. Let's paint a picture. You're part of a 10-person team including a lot of STEM experts all rigorously trained with your equipment and for crisis management. I drop you somewhere on Mars or the Moon, doesn't matter which, with 2 space suits each, a couple boxes of spacesuit repair gear, a bunch of solar panels, a device able to extract oxygen from rock, so long as supplied with electricity, and a device able to recycle water from sweat or urine or impure ice deposits, so long as supplied with electricity, plus spares of each of those devices, and some hand tools, a year's worth of food, some seeds, and a lot of feedstock for that 3D printer. Our remaining kit is all the obvious stuff like lights, batteries, medicine, computers, and so on. What realistically is going to go wrong here that won't kill people in minutes but would get them in a week but not a year? Or where a rescue or resupply on the Moon would help, but if they were on Mars they'd be out of luck? Could they run out of food? Sure, but they aren't keeping all in one place. Presumably you send them with reserves, say 25% more than expected. There is presumably no space bears or space ants going to raid your picnic baskets, so damage would have to be some strange type of unexpected spoilage or some gross physical damage to the site that destroyed either a lot of the camp or by bad luck hit one of your food stores. If you had it all in only 3 spots, even a total loss of 1 with a 25% reserve leaves you 83% of your food left. Tight rations, but not starvation rations either. Of course, maybe a meteor hit and blew up 2 of your 3 reserves. Now you're down to 42% of your food, But odds are good something that destructive killed a couple people at least who now don't need food. Indeed, it probably would have gotten nearly everyone if it also got the food. The type of food you would send for missions like this is not destroyed by a vacuum exposure, so to lose it all to some destructive event would tend to imply the camp took a pasting that destroyed lots of other stuff and killed lots of people. Alternatively, for something like water reserves being damaged on Mars, assuming you have transport, you can go source more from places with ice faster than a ship could arrive from Earth. And if you can recycle your water, you should be able to make do even if only a fraction of your reserves were left. Alternatively, maybe a member of your crew went nuts and started selectively destroying food, or water or air. But why would they do that, and what really is the defense against it? They could overload the reactor, so to speak, and kill everyone, in which case a resupply pod or search and rescue team a few days later isn't really helping either, everyone's already dead. Such breakdowns shouldn't be fast though, and psychologists monitoring base cameras and crew real time for the moon base enjoy little advantage over those watching 20-minute-old recordings from a Mars base. Another thing to keep in mind is that it is really only in the early days that help is coming from Earth. On the moon or Mars, there is likely to be a ship or station orbiting it, or another base, either of which might provide assistance to others and vice versa. One more big factor to contemplate about whether we should put boots on the ground on Mars or the moon next is that wherever that pair of boots first take a small step for man, and another giant leap for mankind, there's already going to be a robot sitting there. Not all landing sites are created equal, and you can plan your mission a lot better if you're not guessing about the site. You will have sent rovers to check the spot out probably before you even started building the ship the folks who will travel there will come on. You will have a very good survey, and you will likely have pre-dropped some supply and gear. A moon base might be partially constructed by robots remotely controlled from home, so that the crew can rapidly assemble and inhabit the facility on arrival. We consider that another big advantage for the moon, but it may be overstated. Consider scooping dirt and shoving or ramming it into crude habitat walls, assembling a solar panel from an existing kit, or having some water or ice oxygen extractor setup, mobile or fed by robots bringing raw material to it, is not exactly some complex chess game requiring an artificial intelligence of prodigious capability to perform, especially given that these are long-term tasks compared to the signal lag time even to Mars. You can't remote control the drone near real time, but you can send it general construction updates and plans. Or maybe you could do it near real time. We often suggest that one of the two Martian moons, Phobos or Deimos, might be better for stops, especially if any of their surface craters contained ice. And nobody really likes the idea of going all the way to Mars just to stop a few thousand kilometers short at one of its tiny little moons, but setting up a base on one might be a very good plan, possibly done by robots in a precursor mission, possibly done by whoever was left on board the main ship as the rest of the crew descends in shuttles or pods. One of the more popular notions for a Mars mission is to send a nuclear reactor there to produce rocket fuel from native ice, which can be used to fuel your return trip to orbit and to Earth, but for all of the millions of kilometers between Earth and Mars, it's those handful of thousands near us that represent most of the risk and problem, especially the last couple hundred kilometers of atmosphere. If either Martian moon contained ice, robot probes might find it and set up a fuel depot there. Of course, another popular reason for going to the moon first is that we can set up fuel production there too. There appears to be ice on the moon, but you don't need ice there or on either Martian moon to make fuel. Aluminum and oxygen make a decent fuel, and there's tons of aluminum on the moon, and there's tons of oxygen any place you've got rock. Aluminum is abundant on Mars too, so also presumably it's two moons. If you can make fuel in space, off Earth, then it makes flying to any other place much easier, because most of the fuel used flying to Mars is flying out of Earth's gravity well to begin with. So if you set up fuel production on the moon, not only does that let you build a more robust space infrastructure near Earth and the moon for sending things to Mars, it lets you send a lot more cargo there to await a manned mission. Supplies left in orbit of Mars or dropped to the surface, either made on the moon or in orbit, or just sent up from Earth but pushed the rest of the way from low Earth orbit using fuel made on the moon. That's probably the most attractive aspect of the moon first scenario. It allows a big buildup of space infrastructure and industry, which is going to make any Mars venture vastly easier and done with vastly more experience of day-to-day off-Earth operations. The moon fuels all that with raw materials and literal fuel. Maybe the biggest thing Mars is often seen as having for it is that it's not a resource extraction site, as we think of the moon or asteroids as. It's a potential new planet we could terraform to be Earth-like, and be home to humanity in our transplanted and adapted ecosystem. However, Venus is perhaps the more logical candidate in this regard, and is closer to us than Mars in both size and distance were it not so hot. Fundamentally, Venus can be made Earth-like in ways Mars really cannot, though terraforming either is way outside the scope of this episode, which is about forced missions and maybe respectably large bases or outposts. We explored how to live in floating cities on Venus in our episode Colonizing Venus, and we explored terraforming both Mars and Venus in our Springtime on Mars and Winter on Venus episodes. Now, we often note that the moon's proximity to us is an advantage, but another argument for Mars is exactly that. The moon is so close to Earth that it does not represent a backup plan. We often think of colonization of space as important for getting all of our eggs out of one basket, and it's hard to imagine how an event that utterly obliterated civilization on Earth wouldn't get our orbital facilities or moon bases too. It's also unlikely the moon would ever be more decoupled from Earth's politics and economics than any of its space stations or continents and islands would be. So if you want to truly set up a backup civilization, Mars is better as a choice than the moon and easier to do than Venus, even if Venus can be done more properly with more time and effort. However, this is where the moons of Jupiter become even more appealing. Jupiter is still close enough to the Sun to make solar power feasible if that's all you got. It's got dozens of moons, 4 of which match or exceed our own moon, and it has plenty of every element life needs. Each of those moons is easily traveled to from each other, and a place like Europa, Callisto, or Ganymede might be ideal for a subsurface colony that was well protected by distance and physical barriers from any chaos or havoc closer into the solar system. So for backups, the moons of Jupiter seem better than Mars, especially as they are plural, and setting up multiple bases on multiple moons, all able to be independent but also easily able to trade back and forth or come to each other's aid, does seem a better backup plan than Mars. You can terraform them too if you really want, see our episode Somewhere on Jupiter for details. Incidentally, for folks who ask, there are no plans for an Autumn on Planet X episode. I get asked about that a lot, and the most popular suggestion seems to be Autumn in the Asteroids. As mentioned, we have no plan for that episode, but asteroids are another alternative first. The asteroid belt has many of the same advantages that Jupiter's moons have, but in this case we mean the asteroids not in the belt. Rather, our interest is in the near-Earth asteroids. Now, near-Earth can mean physical proximity, but what we generally also mean is delta V, or how much fuel it would take to leave Earth orbit and rendezvous with an asteroid. And in this regard, there are thousands of objects that are easier to get to than Mars or even the Moon. Many of these have no shortage of raw materials we could use to fill the same supply role we contemplate for the Moon. A kilometer-wide near-Earth asteroid may be a tiny mote of dust compared to the Moon or Mars, but it's still around 1 billion tons of material we could use, some of which might be precious metals to fuel asteroid mining endeavors financially. There's no real profit model for Mars that I know of, just a new place for people, and even for the Moon, the interest is mostly for raw materials to fuel space exploration or colonization. Your profit model tends to be scenarios like mining and building orbital mirrors to be used in power satellite grids or weather and climate control systems. Near-Earth asteroids also might be better stepping stones to Mars than the Moon. They are just as easily turned into fuel production spots as the Moon, and use less fuel getting free of their own gravity well. What's more, a smaller one, especially one being used to make fuel anyway, can be found that's on a fairly elliptical orbit not too far off from what we contemplate for an Aldrin Cycler. An Aldrin Cycler, a large spacecraft named for Moonman Buzz Aldrin, who refined the concept of cycler spacecraft, is essentially a ferry craft that moves back and forth between cislunar space and Mars orbit. Cyclers are interesting devices that focus heavily on minimum energy Hohmann transfer, as they essentially make a single long eccentric loop around the Sun, moving between those two bodies. In the case of a Mars cycler, it spends 5 months going from Earth to Mars, spends another 16 months out past Mars, and another 5 months again back to Earth's orbit, then repeats the process every 26 months. So you could think of it like a big empty train that drives a scenic route but never stops. You still have to expend fuel as normal to get people, equipment, and supplies to the cycler, but at least you'd have a big comfortable living space for the trip once you did. You could also potentially be producing that fuel needed to fuel those ships, and bump that asteroid into the cycler orbit from the asteroid itself. So which way is best? Mars first, or the Moon, or one of these others? For my part, I still would say Moon first. It still seems the most probable path for a strong and safe emergence into the solar system, But as we saw today, there are other options and strong arguments for each. Indeed, there's many more than we looked at today for those who want to explore the topic more themselves. One word of warning about those, and about our own points for today, so many of the plans drawn up or arguments in support of one of these Mars or Moon endeavors are either based off technology that's always changing, or reliant on technology we don't have yet or don't have fully prototyped and time-tested yet. One small and minor technology could be the difference between Mars or Moon first, simply making one much easier or safer, or one of the other locales we suggested. In the end, time will tell, but I'd still put my money on the Moon as the best shot. Of course, I wouldn't mind being proven wrong. For me and so many others, we don't really care which happens first, so long as it happens, and sooner rather than later. It's been a busy week here on SFIA. In between our two regular Thursday episodes, we had a two-part episode on the geopolitics of space colonization with What If Arthist, and our Sci-Fi Sunday episode, Annoying Aliens, which had an extended edition episode on the top 10 most annoying fictional aliens over on Nebula. And we're still not done for the month, and we'll get to our upcoming schedule in a moment. First though, today's episode was focused on Mars versus the Moon, but I mentioned the possible alternate candidates besides either, and I want to spend more time on Venus's pros and cons, but did not want to shift the episode focus off of the Moon or Mars, so we will be having a brief extended edition of today's episode considering Venus first over on Nebula, our streaming service. And if you're looking for more content on Mars, there's a number of great shows on the Red Planet like Packing for Mars over on CuriosityStream. And if you'd like to see that extended edition of today's episode, looking at Venus first, Sunday's Annoying Aliens Top 10 list, or any of our other extended episodes, those are available on Nebula, our streaming service, where all of our episodes air early and ad and sponsor free, alongside some exclusive episodes like our Coexistence with Aliens series. There's also many other excellent creators there who put out exclusive or bonus material. Now you can subscribe to Nebula all by itself, but we have also partnered up with CuriosityStream, the home of thousands of great educational videos, to offer Nebula for free as a bonus if you sign up for CuriosityStream using the link in our episode description. That lets you see content like Packing for Mars and watch all the other amazing content on CuriosityStream, and also all the great content over on Nebula from myself and many others. And you get all of that for less than $15 by using the link in the episode's description. So after 4 episodes in a week, one is a 2-parter and 2 extended editions, we will be catching our breath until next Thursday, where we will celebrate our 300th regular episode here on SFIA by leaping into the distant future to look at the end of Earth. Then next Sunday, July 25th, we will have our monthly livestream Q&A. Don't forget to join us then to get your questions answered. Then in 2 weeks we will have the 3rd episode of our new series, Galactic Domination, The Galactic Laboratory, which will finish us out for July on the 29th. If you want to know us when those and other episodes come out, make sure to subscribe to the channel, and if you'd like to help support future episodes, you can donate to us on Patreon or on our website, isaacarthur.net, which I'll link in the episode description below, along with all of our various social media forums, where you can get updates and chat with others about the concepts in the episodes and many other futuristic ideas. You can also follow us on iTunes, SoundCloud, or Spotify to get our audio-only versions of the show. Until next time, thanks for watching, and have a great week.